Many people say a little ethanol in your fuel is totally fine. This is the simple myth we hear all the time. It sounds reasonable, doesn't it? A little bit of something can't hurt. But today, we are going on a high-octane quest to test this very myth. We will not use opinions. We will use clear, undeniable facts. We will arm ourselves with simple numbers and data. Together, we will prove exactly what happens when the ethanol level in your gasoline goes too high. This is not a story of maybes. This is a shonen-style takedown of a dangerous assumption. Let's power up and get started. Ethanol is essentially a type of alcohol made for your engine. It is a biofuel, typically produced from plant materials like corn sugar cane through a fermentation process. Fuel manufacturers blend this ethanol with standard gasoline for a few key reasons. One major goal is to make the fuel burn cleaner, which can help reduce certain tailpipe emissions. This mixture is what you see at the pump labeled as E10, which means it contains 10% ethanol. For many modern cars, this E10 blend is perfectly acceptable. But the real story begins when that percentage starts to climb, because that is when the hidden problems can appear, often with surprising speed and force. The myth we are busting is the idea that a little more ethanol is harmless. If E10 is okay, then surely E15, E20 must be fine too, right? This line of thinking is where the danger truly lies. It ignores the precise engineering that goes into your vehicle's fuel system and engine components. Not all cars are created equal. Older vehicles, classic cars, marine engines, and many modern cars not designated as flex fuel are not equipped to handle higher concentrations of ethanol. They were built for pure gasoline or very low ethanol blends. Ignoring this can be a costly mistake. We will break down the effects of ethanol overload piece by piece, like a mechanic disassembling an engine. We will look at how it affects your mileage, your power, and the very materials your engine is made from. We will explore the science behind rough idling and the dreaded lean burn condition. By the end, the myth will be completely shattered. You will have the power to protect your engine and make informed choices at the pump. Let's ignite the truth. First, let's talk about a problem you will feel directly in your wallet. Fuel economy takes a nosedive. Fuel economy takes a nosedive. When the ethanol content rises, your car uses more fuel to travel the same distance. The reason for this is simple chemistry. Ethanol contains less energy density per liter compared to pure gasoline. Think of it like trying to run on diet soda instead of a full sugar energy drink. You just need more of it to get the same kick. The engine's computer detects the lower energy and injects more fuel to compensate, leading to a noticeable drop in efficiency. Tests and real-world data consistently show a measurable drop in mileage even with standard E10 fuel. E10, around 3% to 5% compared to ethanol-free gasoline. It adds up over thousands of miles. Jump to an E15 blend in a non-flex fuel vehicle, and that drop becomes more significant. Drivers can expect their mileage to decrease by a staggering 7% to 15%. Beyond your fuel budget, your engine's performance also takes a direct hit. The power output, the very muscle of your car, begins to fall as ethanol levels increase. With E10, the drop might be small. At E15 or higher, the reduction in peak power becomes much more apparent. This 1-2 punch means you pay more often for a weaker ride. That's the first major crack in the myth. Have you ever stopped at a red light and felt your car start to shake or shudder? That unsteady vibration is known as rough idling. When you introduce higher levels of ethanol into a system not designed for it, you can trigger this very problem. The smooth, steady rhythm is replaced by an inconsistent sputtering. This happens because ethanol changes the way fuel burns. It can disrupt the delicate air-to-fuel ratio your ECU strives to maintain. Ethanol is an oxygenated fuel. Blended in, the mixture becomes leaner, more oxygen relative to fuel. In a non-flex fuel car, ECU adjustment range is limited. If ethanol is too high, the ECU may not compensate, causing misfires and rough running. Lean burn can spike combustion temperatures. This heat punishes pistons, valves, and cylinder heads, leading to premature wear, detonation, engine knock, even catastrophic failure. The rough idle is your engine's cry for help. It's a critical warning sign of incompatible fuel. This internal tremor busts the myth of harmless ethanol. Section 4. Corrosive chaos, the chemical assault on your engine's guts. Ethanol is hygroscopic. It absorbs water. Water separates and settles at the tank bottom. Water ethanol on metals drives corrosion. Aluminum is vulnerable, leading to pitting in tanks, pumps, carb bodies. Pits flake, particles clog filters, starving fuel, causing hesitation, stalling, power loss. Debris can damage injectors. Ethanol is a strong solvent. Older rubber hoses, seals, gaskets, O-rings swell, soften, crack, or turn brittle. Degradation risks leaks. Vapors plus heat equals fire hazard. Inspect lines, seals, and hoses, especially on older cars. The damage is real, chemical, and a safety threat. Section 5. The final verdict, your action plan for engine survival. E10 is manageable for most modern cars. Forcing higher blends into an unprepared engine is a recipe for disaster. It robs mileage, it robs power, you pay more for a weaker ride. Action plan. Check the manual, know the max ethanol. Most cars, E10. Flex fuel, up to E85. Look for yellow cap or badge. Never exceed the limit. Inspect lines and hoses. Replace aging rubber and plastics with ethanol-safe parts. For storage, use stabilizer and keep the tank full.